Okay, welcome back to part 2 of lesson 84. I hope you had a chance to try questions 3 and 4. Okay, so looking at example 3, I know that you won't get tricked by the first term because dy by dx is attached with x, right? So the first thing that we have to do is to divide every single term by x. And I have minus cos x equals to negative y over x. But we have a second problem here. Our second problem here is that, well, my y doesn't appear in the second term, right? But it's on the right side right now. So that means I should do this. Rearrange it so that now we have a linear differential equation. And then time for an integrating factor. E to the power of the integral of 1 over x dx e to the ln x, which is x. So I have x dy by dx plus x times 1 over x is 1 y, and then here I have x cos x. Left side now is the product rule. It's the derivative of x times y. And then your right side is x cos x. Now you know why I was laughing, right? Because in the next step, we know we integrate. Left side is easy. It's just xy equals. How would you integrate the right hand side? Do you notice that this is integration by parts? Okay, so x cos x is a very typical integration by parts question, correct? What do we have here? We have let u be x, let dv be cos x dx, so that du is dx. V is the integral of cosine, which is sine x. I hope I did it correctly. And then applying the formula, uv is x sine x minus v du integral sine x dx. Okay, not so bad. xy x sine x. Well, negative, this is negative cosine, so plus cosine x plus c. So y is, divide everything by x. I can say this is sine x plus cos x over x plus c over x. And that's it. Now let's take a look at example 4. Consider the differential equations. Okay, so this is a differential equation relating x and y. A, show that the substitution z equals to y cubed transforms the original equation into this new equation, which involves dz by dx. So in my mind, I will be speculating something about chain rule, okay? Because we're connecting 3 different variables here. Well, since we're thinking about chain rule then, I'm going to just start by taking dz by dy and see what's equal to 3y squared. Okay. And I noticed that there is actually 3y squared in our original equation. So perhaps we have to do some substituting and replacing, and hopefully we will get to a point that will allow us to, condense these derivatives, okay? So I'm just going to start by copying, but rearranging the original equation. Okay. With the substitution, 3y squared turns into dz by dy multiplied by x multiplied by dy by dx, and then plus y cubed is z equals to e to the x. Well, this is x dz by dy times dy by dx. I'm just going to rewrite it so it looks more obvious. By chain rule, we can express this now as dz by dx, which is what we need. Okay, and this is shown. Part B. Hence, find an expression for y in terms of x. Now, this new version of the differential equation certainly looks more simple than the original question. And if you look closely, I can actually divide every single term here by x to arrive at a linear differential equation. Okay. And so, because it's not y anymore, right? It's actually x and z. And this z in the second term does take up the place of y that we usually see in that exact differential equation, which means that we can certainly work out an integrating factor. Which is x. Multiply this to every single term of this differential equation. I have d by dx of x times z equal to e to the power of x. And then you can integrate both sides. I get x z equal to e to the x plus c, meaning that z must be e to the x plus c over x. And now we can do some back substitution, knowing that z was y cubed, I believe. Yep. So I have y cubed equal to e to the x plus c over x. And so y is the cube root of this expression. There we go.